Hi everyone. In this video, I'm going to explain concepts paper of data science. My name is Kanare from class Undergraduate Fifth Provide an example. First, hypothesis driven. Start with the theory. Then collect data and run tests to confirm the hypothesis. Data driven. Start from the available data. Explore it to final patterns. Generate hypothesis. Predictive models without a strong prior theory. Rule of hypothesis test casually for specific scientific claims of data driven. Discover patterns, build accurate predictions, or generate new hypotheses. Method of hypothesis driven experiments, control trials, A/B testing, statistical hypothesis test, even confidence intervals. Method of data driven exploratory data analysis, feature engineering, machine learning, unsupervised learning, model selection. When you use hypothesis, when you have prior domain knowledge of the theory, when data driven, when large databases exist but theories. Example, user behavior on website. Example of hypothesis, rabbits reduces blood pressure more than plus. Data driven, using take strain loads to cluster users and risk unexpected customer segments, then building recommended systems. Finally, difference between structured and structured qualitative and categorical data with suitable real-world example. First, structured data. Structured data organized in tables, fields with fixed schemes, rows and columns. Example, relational database system and table. Characteristics very vary for fixed format strings. Second, unstructured data, no prediction, no predefined schema, text, images, audio, and video. Example, customer support emails, product images, forwarding. Characteristics of unstructured data requires computer vision with strict features. Third, quantitative data, numerical values that represent points on measurements. Types, continuous or discrete. Example of quantitative house price, age, salary. Categorical data, discrete labels or categories, often non numeric, types, non nominal or ordinal. Example, payment methods, customer satisfaction. Question number two. Write an algorithm that uses Bayes theorem for discussion method. Discussion making. Step 1. Start. Step 2. Identify the set of possible classes events for discussion making. Step 3. Collect prior probabilities for each class. Step 4. Collect likelihood values for evidence E for each class PEC1, PEC2, PECN. Step 5. Communicate marginal probability of evidence. PE equals to summation of PECI dot multiply with PCI for all classes I. Step 6. For each class compute posterior probability using Bayes theorem. Step 7. Compare all posterior probabilities PCIe. Step 8. Select the class with the highest priority probability as the decision outcome. Step 9. Display the selected class. Step 10. Stop. Question number 2, part B. Write any suitable algorithm for association rule mining that can be print all association rules. Step 1, start. Step 2, input the transitional databases. Step 3, select the minimum support and minimum confidence thresholds. Step 4, generate all frequent item sets from the database using the a priority property. Step 5. For each frequent item set, generate all possible non-empty subsets. Step 6. For each subset S of frequent item set F, calculate confidence support F divided by support S. B. Confident minimum confidence, then form the rule SFS F minus S. Step 7. Store print all association rules that satisfy confidence threshold. Step 8. Stop. Question number 3. Compute mean, mode, and median and a standard deviation for a given small database. Explain when each measure is appropriate.
Example, dataset 2, 4, 4, 6, 10. Mean, arithmetic mean, mean calculation is equals to 26 by 5 equals to 5.2. Median is equals to mid value is 4. Mode equals to frequent value, mode is equals to 4. 4 appears twice a time. Standard deviation is equals to squared deviations. 2 minus 5.2 square equals to 20.24. 4 minus 5.2 square equals to 1.44. 4 minus 5.2 square equals to 1.44. 6 minus 5.2 square equals to 0.64. 10 minus 5.2 square equals to 23.04. Sum of squares is 30.36.8. Population variance is equals to 36.8 divided by 5 is equals to 7.36. Sample deviation. Sample SD is equals to root 36.8 divided by 5 minus 1 is equal to root 9 minus 2, which is equals to 3.033. Use SD to measure spread when mean is meaningful sensitive to outliers. Question number 3, part B. What is the difference between errors and artifacts in data cleaning? Explain any two imputation techniques. Errors versus artifacts. Errors. Incorrected data values due to input mistakes, sensor faults, transmission error, or human entry. Example 2000 instead of 20. They are invalid or incorrupted values. Artifacts. Systematic distortions introduced by measurement process or pre-processing. Example, duplicate row. During to login, rounding bias sensors. Calibration bias. Artifacts may be consistent but not true values. Two imputation techniques, mean median imputation and second k nearest neighbors. First, mean median imputation. Replace missing numerical values with column mean. Priors, pros, simple, fast, preserve data size. Cons, underestimates variance, may bias correlations. K nearest neighbors, KNN imputation. For each missing value, find K nearest records other features impute using mean of neighbors' values. Pros, use multivariate relationships can preserve structured. Cons, computationally extensive, or to scaling and choice of K. Question number 4. Explain any four common features engineering techniques for continuous or categorical data. First, scaling, normalization, standardization z equals to xu minus sigma, useful for algorithms sensitive to scale, SVM, KNN, gradient distance. Mean max scaling maps values to range 0 to 1. Preserve distribution shape but is sensitive to outliers. Second, binding discretion converts continuous value into categorical bands. Example age 0 to 18, 19 to 35, 36 to 60, 60 plus. Can be done by fixed width beans or quantile beans. Helps capture non-linear patterns and reduce noises. Third, encoding categorical values. One hot encoding creates separate binary column for each categorical based for normal variables. Cardinal encoding assigns integer values to ordered categories. Example, low 1, medium 2, high 3. Target mean encoding replace category with mean of the target variable. Use with cross validation to avoid data leakage. Fourth, feature interactions. Create interaction terms such as x1, x2, x1 square, x2 square, etc. Helps models capture hidden nonlinear relationships, especially linear models. Fifth, List generations indicators. Add a binary column indicating whether a value are missing 0, not missing, 1 equals to missing. Useful when the pattern of missing values is informative for prediction. Question number 5. Distinguish between parametric versus non-parametric models and supervised versus unsupervised learning with examples. Parametric models assume a finite set of parameters with fixed dimensionally. Example linear regression with coefficients. Pros simple, fast, neat, less data. Cons may be biased if model misspecified. Example linear aggregation, logistics regression. Naive bias. Non-parametric models No fixed parameter count. Complexity grows with data. Pros can model complex relationship. Cons require more data, can be slower. Example KNN decision trees, kernel density estimation, Gaussian processes. Supervised learning, learn mapping from input X to target Y using label data. Example regression, classification. Key methods learn linear logistic regression, SVM, random forest and neural networks. Unsupervised learning discovers structure from unlabeled data, clustering key means, dimensional reduction, association rules. Use cases, customer segmentation, abnormality detection, feature learning. Question number 5B. Define accuracy, precision, recall, F1 score, and illustrate their computation using a confusion matrix. Confusion matrix. Prediction positive divided by negative versus actual positive divided by negative. TP equals to true positions, FP equals to false positives, FN equals to false negatives, TN equals to true negatives. Accuracy. Accuracy represents all our fraction of correct predictions can be misleading when classes are imbalanced. Precision. Precision equals to true positive divided by true positive plus false positive. Out of all predicted positives, fraction that are truly positive, highly precision means fewer false alarms. Recall. Sensitivity, true positive rate. Recall equals to true positive divided by true positive plus false negative. Out of actual positives, fraction correctly identify high recall means fewer missed positive cases. F1 score. F1 equals to 2 into precision divided by multiply with recall divided by precision plus recall. Harmonic mean of precision and recall useful when data set is imbalanced and the balance between precision and recall is needed. Example TP equals to 70, FP equals to 10, FN equals to 20, TN equals to 900, total is 1000. Accuracy is 0.97, precision is 0.875, recall is 0.77, F1 score is 0.8253. Question number 6. Describe how the coefficient in linear regression are estimated using either the closest form equation for gradient descent linear model, where x is defined matrix and beta is the coefficient factor in ordinary least squares where maximize and the closed form solution is beta, assuming pros of LOS exact solution fast for small medium databases, cons computationally and memory expensive for very high dimensional data and numerically unstable when features are multicollinear. Gradient descent is the interactive method to maximize with update rule where the gradient is equals to variant include batch GD and mini batch GD pros scalable for large database supports streaming data and regulation cons requires learning rates turning and converged monitoring solution is proximate and exact regularization rich modified solution 2 lasso recurrences had no closed form solution and is solved using convex optimization practical notes features improves gradient descent convergence residuals and assumptions like linearity homoscedasticity and independence should be checked in practice. Question number 6B. Explain logistic regression and use the logistic function to calculate probability of a class for a given input example. Logistic regression models the probability of a binary outcome where y belongs to 0 to 1. It uses a linear combination followed by a sigmoid activation z equals to wxt plus b. Probability of the positive class is communicated as p is equal p y equals to 1 divided by x equals to sigma z equals to 1 plus e की power minus z. The output of the model is always between 0 and 1 and represents probability. A decision threshold is used to convert the predicted probability into a class label. The model is trained using log loss Parameters are optimized by maximizing likelihood or minimizing negative log livelihood using gradient descent or Newton's method. Example for W 0.5 minus 2 minus 1, B equals to 0.2, and Z equals to 2 comma 3, and Z equals to 1 minus 1.8, and P equals to sigma 1 minus 8 is equals to 0.1419. So prediction is class 0 when using threshold 0.5. Logistic regression can be extended to multi-class classification using softmax. Regulation L1 or L2 is used to prevent overfitting. Question number 7. Right K-means clustering algorithm discuss how initial centroid influence result. Claim in clustering. Convergence criteria stops when the cluster assignments do not change or the change in inertia. Outputs cluster labels for each data point, centroids for each cluster, impact of initial centroids, optimize a non-convex objects prone to local minimize, different initial centroids, different final clusters, and inertia. Poor initialization may cause empty cluster, slow convergence, subproportional clustering. Remedies came in plus initialization, probabilities, seeding, faster, better cluster, multiple runs with different seeds, choose solution with lower inertia, domain knowledge, smarter placement of initial centroids, came in algorithms step by step. First, initialize k centroids. Second, assign each data points to the nearest centroid. Third, update centroids at the mean of point assigned to each other. Fourth, check converge stop with the assignment. Do not change or inertia change. Tolerance. Repeat step 2 through 4 until convergence. Question number 7. P. Write k nearest neighbors k in an algorithm using Euclidean distance (KNN) nearest neighbors instance-based classifier input training set query point x integer k distance metric distance most common d xy xi comma x into summation of xij minus xj square. Algorithm steps. First, compute distance from query point to every training sample x. Second, sort all training samples by increasing distance. Third, select top k nearest neighbors. Fourth, prediction. Classification majority vote of neighbors. Class labels. Regression. Average of neighbors. Target values. Nodes. Key points. First, feature scaling required because distance is scale sensitive. Time complexity big O and D per query n equals to training point d equals to features can be accelerated using KD tree or ball trees in low dimensional data. Choice of K, small k, high variance, overfitting, large K, high bias, over smoothing. Use cross validation to select optimal K. KNN is a non-parametric and lazy. No explicit training computation happens at query time. Question number 8. Compare decision trees, random forest, and boosting, highlighting strengths and weakness of each. Decision tree. Strength, interpretable, easy to visualize, handles numeric and categorical features, little data preparation. Weakness, prone to overfitting, unstable, greedy splitting, may miss goal optimum. Random forest, strength, reduces variance, robust, often good out of the box accuracy, handles high dimensional data, less prone to overfitting, provides features to important estimates. Weakness: less predictable and single tree, larger memory time for many trees, can be biased for a categorical variables with many levels, less unpredictable, partial dependence or a shape used for explanation. Boosting strength: build strong predictive models by sequentially correcting errors, often state of the art, and handle approx relationship feature interaction. Weakness: more sensitive to hyperparameters, risk of overfitting is not regularized, slower to train, more complex to tune, less unpredictable partial dependence on SHP used for explanation. Question number 8. Describe Spark and its advantages over MapReduce. Apache Spark overview. Distributed data processing engine in memory computation. Support batch streaming SQL ML. Main abstraction RDD. High level APIs. Data frame datasets. Core components, driver, executors, cluster manager, libraries. Advantages over MapReduce. In memory computation, Spark keeps intermediate data in memory much faster for interactive algorithms than MapReduce, which writes to disk between each job. Un- Unfilled engine supports batch streaming SQL ML in same framework. Better performance, lower latency, and fewer disk input-output operation. When MapReduce is still useful for very large simple batch jobs on disk web when memory resources limited, but Spark is generally performed for modern use. Question number 9. Obtain basic logic gates from neural networks summarized then in table with number of neurons, activation function, and backpropagation in neural networks. Gate and gate. Minimum neuron 1. Architecture single perception. Activation function step or sigmoid. Training backup. No training needed if weight set manually. OR gate. One neuron, single perception, step or sigmoid, same as AND gate. NAND gate. One neuron, single perception, step or sigmoid, same. NOT gate. One neuron, single perception, one input. Activation function, step or sigmoid. Training, same as AND gate. XOR gate. Two neurons, hidden layer. Two neurons, two hidden layer plus one output. Activation function sigmoid. Training required training using backpropagation to learn weights. Backpropagation. Backpropagation used to train multi-layer networks like XOR gate. Compute gratitudes of less with respect to weights via chain rule. Update weights with gradient distance. For single perception with step activation, classical propagation perception learning rule used instead differentiable activities sigmoid enable backprop. Question number 9. Compare CNN, RNN, and GNN and transform learning in terms of architecture and applicants. CNN architecture convolutional layers, pooling layers, fully connected layers, spatial weight sharing, and local connectivity. Strength efficient spatial feature extraction, translation invariance. Application image classification. RNN architecture sequential model with recurrent connections. Application sequence data in language modeling, speech recognition, time series forecasting. Strength model temporal dependencies. GNN architecture, two network generator and discriminator. Application image synthesis, style transform, super resolution, data augmentation. Strength produces high quality elastic samples. Transform learning idea, reuse pre-trained models like and fine tune for new target task. Applications fine tuning CNS for customer. Transform from LNP task. When to use when label data is limited. In this video, I explain all questions of end semester. Thank you.